Hi everyone. You're welcome to today's webinar. We're sorry we're starting a bit behind time. So today we're talking about the InVEST model. That's the integrated valuation of ecosystem services and trade-offs. As we keep striving for a better ocean, we think it's necessary to equip ourselves with the right knowledge and tools that will facilitate decision-making and conservation efforts. And here we have Dr. Famara. I'm sorry, I hope I'm pronouncing that very well, who will be taking us on this journey. And that being said, please, you have the floor now.
All right, well, thank you very much, so for that very kind introduction. So let's see. Okay, so let me give a little bit of context. I am Famara Dampha. Famara Dampha would be a similar way to pronounce his name. I'm Gambian. I'm based in the US. I'm a research scientist at the University of Minnesota's Institute on the Environment. I'm also the program director for the Natural Capital Project at the Institute on the Environment. So NatCap, as we will call it, as the Natural Capital Project, is a multi-institutional partnership among Stanford University, University of Minnesota, the Chinese Academy of Sciences, the Stockholm Resilience Center, WWF, and TNC. So NatCap came into existence about since 2007. It's been almost 15 years now. When it started, it focuses on developing tools, basically to use technology, software to come up with models. So we've developed, I'm gonna close my window for the noise. Sorry about that. A bit noisy here. So we've been developing models. Many of you may have checked the website already. If not, that's okay. But we have several models. We call them integrated valuation of ecosystem services and trade-offs models. So in short, those are called InVEST suite of models that we have. I think most of our models are focused on terrestrial ecosystem service assessments and valuation instead of more on the marine side. There is a lot of interest in the team to think more about how do we come up with more marine focused models. So that's in development, I would say. So what do I want to talk to you about today? First, if this was a smaller group, we could kind of have an idea, kind of gauge your awareness, your level of understanding of what InVEST is. But given that we have about 15 people in the room, it's going to take time to do that. So I'm just going to assume that some of you have some understanding, some of you are basic, don't know much about InVEST, and I joined this webinar to get a little more information. And just background research-wise, my research focuses on climate and natural resource economics. So I think a lot about nature's role in building climate resilience, but also contributing to climate mitigation, as well as how climate change affects natural ecosystems. So this is an interaction there. It's like how nature contributes, but also how nature is being affected by climate drivers. So what I thought I could do, because you wanted a case demonstration of the use of one of these tools, or so a couple of tools that we have, I just decided that maybe I talk about a project that we recently completed in Burundi. This is a project funded by the World Bank, and our team members were tasked to do a climate risk assessment that includes an ecosystem service assessment to kind of look at nature's potential, particularly nature-based potentials for reducing climate risk, as well as for building climate resilience in Burundi. So it's an analytics. The World Bank calls it ASA. It's basically like a research study, if you like. And I have to acknowledge the number of people who were involved in this work, including the Red Cross Climate Center, of course, our colleagues at Stanford University, even the government of Burundi, and some of our colleagues at the World Bank. I have to say, I also consult for the World Bank. That's why I'm bringing this here. But just using this as a demonstration case, not speaking on behalf of the World Bank by any means here, but I'm a senior climate consultant for the bank, mostly working in Burundi and in the Gambia. So this is too much into what you want to know, but this is just a summary of what we did in Burundi to kind of show you how you could do multi-hazard or multi-risk hotspot mapping. So we look at hazard, we look at vulnerability, and we also look at lack of coping capacity in Burundi. So we use a framework called Inform Index, which kind of looks at, again, risk from a component, from three components. So you have hazard exposure, what is the current vulnerability level of the people, mainly looking at socioeconomic vulnerability, and what resources and assets are available within that country to minimize people's vulnerability to these hazards. So a bunch of hazards here. A lot of them are climate related, from landslides, floods, droughts, wildfires, to even conflict related. And this is conflict associated with land, for example, land related conflict as a result of some of the social fragilities in Burundi. So here's where it was interesting for us. This result number one on land, on environment, land, and forest is really dependent on the use of the InVEST models. And I'll tell you, a bunch of models went into generating that map. But what that is showing you, it is looking at nature-based potentials, basically potential areas across Burundi where nature could be leveraged to reduce climate risk and build resilience. And I know that many of you are interested in the marine sector, but of course we know that there is a natural interaction between terrestrial ecosystems with the marine ecosystem. What happens upstream on the terrestrial ecosystem affects the marine system. So there's a specific model that will show us an interesting demonstration of how that these two are in a link or interrelated. I'm not going to bore you with the rest of these recommendations, but I'm going to go straight and give you a specific example of how we use InVEST after doing the risk assessment in Burundi. So we did the risk assessment. Now we know where hotspots are when it comes to hazard, vulnerability, but mainly hazards. And then the World Bank is now preparing a project on building infrastructure resilience. So it's a transport project. It's supposed to build roads and stuff like that. So they asked our team, how do we think about transport resilience through nature-based interventions? So what is nature's role in strengthening this infrastructure of our road system that we are going to build? So we know in the literature, we know there's an interesting connection between gray and gray infrastructure. We know that green infrastructure, as some of you will call it, which is similar to nature-based solution, provides some sort of resilience to maintaining hard infrastructure. We know even from the villages that we come from, once you have these big trees in front of your house or at the backyard of your house, it minimizes the vulnerability level of that infrastructure when it comes to climate extremes like windstorms and the like. So we know trees could do that for infrastructure. For roads also, it was interesting because in Burundi, we wanted to make sure that when we minimize landslide risk in these locations, we are also contributing to minimizing the destruction that landslides or mudslides cause to infrastructure, especially to road infrastructure. We've seen blockage in some of these communities where the landslide occurs and the road gets blocked. And then essentially what happens is like economic activities cannot progress, people get all these things, communities get affected, access to markets it becomes a problem and all that stuff. So what do we want to do? We wanted to see, okay, how can this project think about restoring degraded upstream areas of the road network to minimize not just landslide risk, but also minimize flood risk. We know how flooding in some of these locations also affect roads. So that was the basis of thinking about what is nature's role there, is how can it help us in minimizing landslide risk. And we know, how do we know that if you build strong nature-based structures, trees and reforest degraded areas, we know that helps to stabilize the soil properties and minimizes any risk of mud or landslide in specifically. So what we did was to look at 3 different models to see how could nature contribute to this project. And these models, InVEST models, would be our carbon storage and sequestration model. Again, it's a terrestrial base because it's used in land cover. But I think 2 other models that may be interesting to you as marine people in the marine science may be related to our seasonal water yield model and sediment delivery retention. So I'm not going to bore you with all this text. It's not meant for you, but this is just giving us a background of what exactly is Burundi vulnerable to, which I've already talked about. Now let's just go into InVEST directly so we can save time. So these are the 3 models. We have carbon storage and sequestration, seasonal water yield, and sediment delivery. What did we do? So if you look at this map, now you can see the black line, that is the road project. That's where the transport project is investing in. Now we have a catchment. We have to look at the geography of the area. So what we did is to look at, okay, what is the main watershed that determines flow direction and flow accumulation. That flow direction and flow accumulation is going to have a direct interaction with what? With Lake Tanganyika. So here we're looking directly opposite where you're seeing these little lines. That opposite of this is Lake Tanganyika, right? Of course, you can see elevation. So we extracted that catchment, that basin here, which is this is the catchment and basins. We extracted that map, and what did we do with it? Now we have, this is to start with, this is our carbon model. Our carbon model looks at 4 different carbon pools. We look at above biomass, below biomass, underground basically biomass. We look at soil carbon and also dead carbon. That's woods and stuff like that. So the model specifically, I know there was interest for me to do a demo. We could do that, but this is the interface of what you see from our platform. You have something like this. So everything there has to be green before the model can run. Sometimes everything is even green. You run it. There are some minor bugs that you need to debug. So, but what do you need here? What are the input data sets that you need? First, you need land cover data. And if you want to do a change, basically look at the change over time in terms of carbon stock, that is the sequestration, you need to give it a different land cover map. That could be a feature land cover map, or it could also be retrospective. You could look at past, for example, in 2000 versus 2020, or you can say, now we're going to do a projection. We're going to see if we do something 2020, what happens with the interventions that we do, what happens to land cover by 2040. So in this case, it was to say if the project invests in restoration that takes about 20 years, right? What happens to each of the different land cover classes? Particularly, we're targeting degraded land. Remember, from our analysis, we saw a lot of land degradation ongoing in Burundi as a result of climate. Some of it is human-induced, deforestation and the like. So if we should restore these forests back to that state of reforested state, then what do we gain? We gain 2 things. First, we gain the stock, a change in carbon. So that's the sequestration, how much carbon you gain over time after 20 years. The second is that we can calculate the social cost of carbon we can calculate the economic value basically of that sequestered carbon by using the social cost of carbon. And with the World Bank, wait, something happened? You lost my screen? Did you?
Because I lost.
You cannot see it?
No, I can see it.
Oh, something happened. It just stopped sharing. I don't know why. All right, I'm gonna get you back here. Okay. So I want to just go quickly and show you the results, right? What are we seeing here? So now what did we do? It's very simple, right? So I did say that we have a current land cover map. All we needed to do to get a feature land cover map is now to do that flipping of the pixel. Now we go pixel by pixel, at least within the target study area, to say, we really want this degraded grassland area to be reforested back to forest. And that's going to take us 20 years to do that. So what happens now? We look at the stock. This is the carbon. This is the difference we see in stock. We see an increase in carbon stock as a result of that. You could see it on the map. Even the darker colors show you where you gain carbon, right? And interestingly, we can look at that also from a table. We can look at the gain that we've registered is over about 3.5 million metric tons of carbon basically sequestered over 20 years. And if we do the social cost of carbon, depending on which theory you're going with, which scenario you're going with, if you are going with RCP 4.5 or 8.5. If it is 8.5, you see a different number, which is in fact is more, because the damage to society is higher under RCP 8.5 than RCP 4.5. That's why you see 154 million compared to 96 million under RCP 4.5. Okay, then that's basically the key finding. Now, what are we able to say, summarize this? We could say the model results suggest that incorporating nature-based solutions, okay, on an average hectare of degraded landscape in Burundi could sequester about 273 tons per year of carbon between this period. So you get that gain. In fact, this is incremental, but over time, the stock increases over time. But one thing about the InVEST carbon model is a linear projection. We know that in reality, it doesn't work like that. The latter years will sequester, once the trees grow higher or bigger, they sequester more than when they are smaller. We know that, right? But this is just a linear projection of what you see over time. And we see the difference when as I said, comparing RCP 4.5 to 8.5. So those numbers there. For each hectare, the economic value to society would be about 7,555 under RCP 4.5 and about 12,000 under 8.5. So the scenario also matters a lot. So in other words, we're saying if this project considers this restoration, the economic value to society is even higher overall and varies by scenario. So these are the limits, like I said. This is a very simplified carbon model. It's a static inventory. Every hectare is identical. And in reality, that's not true. We know that some hectares will get more than others. Also, the other limitation of the model is that it does not occur, the sequestration does not occur in an area unless there is land use change over time. We're keeping the other pixels constant. We're saying that if everything remains the same under these two scenarios, for everything else, unless if we change the pixel, right? The economic valuation is also a linear trend projection over time. Here's where it's getting interesting for you, because now we're talking about what? Water. We're talking about the hydraulic system. And what is interesting about that is to look at the water budget, right? If we look at the water budget, the water balance equation, we know there is precipitation. We know that that amount of water that is precipitated, some of it is evapotranspirated, right? Trees take their part. Of course, ordinary landscapes like water anywhere else also gets transpiration, right? And we know that some of this water flows. That's what we call quick flow. When it rains, it goes runoff. Some of that water percolates, basically infiltrate into the ground to recharge the groundwater aquifers. Some of it is not getting to the groundwater aquifers. Some of it is just going what we call base flow under the subsoil movement of water. That base flow contributes to the stream network or the stream flow, if you like. So that's what this model is demonstrating. It's like, okay, if you consider all these parameters from the water budget, what happens? What do you gain? This is a little more complicated than the carbon model because this one requires more inputs. Here you need a DEM, digital elevation model, right? You need a land cover, of course. You need precipitation data, evapotranspiration data, number of rainfall days or rainfall events. You need soil data, and you also need the climate zone because globally we have like different climate zones. So that's the model interface here on the right side. You got to put in all these inputs for the model to run again. And some of the data to run this model are globally available data sets. So you could run this model. Once you take your time, you go through, for each country, you are able to extract this data from globally available data sets that are out there. The model outputs will be mainly three. One is monthly quick flow rate. And then the second is an index, which is the local recharge, is the recharge potential for every given pixel, given all the parameters that you have. And the third one is the contribution to annual base flow. So base flow is annual, whereas quick flow is showing you monthly. Because the quick flow, we make it monthly because we know that rainfall, in many places, the rainfall period, we're interested in monthly results than annual. But base flow is okay because that connects to the stream and stream. So what do we get? So in this case, again, we have two scenarios comparing. We have the current scenario, runoff, without, basically no nature base. Just use the current landscape and tell me the results given these parameters that we included in the model. And then the other scenario says, well, let's do a projection, but now I want to change some of the pixels. I want to intervene and do some restoration programs here and there. What happens? So without nature-based solutions, we see that the quick flow within the catchment area averages at 372 millimeters per pixel. So that is equivalent to about 4,000 mm of runoff per hectare. When you compare that with nature-based, what we see here is that we reduce quick flow. So you can see the difference in the number. It's not that much per pixel, right? But if you're looking at it per hectare, it's about 90 something. So I think what this is communicating is that nature-based can help to reduce flood risk. Because if you reduce runoff, no matter how small that may be, that reduces the risk of flooding, especially in downstream locations, right? So that's the key message here, right? Another way this connects to the marine system is that in Burundi, for example, you could see the darker blue colors are showing where the highest rate of runoff is occurring. See what's happening in Lake Tanganyika? The water is running quickly into the lake as a result of heavy precipitation. So what nature does there is to minimize. It doesn't stop it entirely because you need really heavy investment for that runoff to be completely or significantly minimized. But you make some progress in reducing. And where this is important also, it reduces what? Sediment transport, because runoff sends pollutants into the water. So with these nature-based solutions, once runoff rates are reduced, you're also reducing the export of some of these harmful pollutants into the marine system. So that helps to improve the water quality there, right? But the other aspect that this may be interesting for, especially in Lake Tanganyika, is that if you have too much runoff into the lake, you are also contributing to increasing the water levels in the lake. So once that water level continues to increase, imagine for a period of 6 months or 3 months of rain, you see rising levels of Lake Tanganyika, and that water is now coming back to affect coastal settlements around the lake. So these are some of the things that this model helps you. Now we're looking at base flow. See, even base flow has more moving towards Lake Tanganyika than runoff. See, the darker green colors are showing you where highest flow is going as a result of the annual underground movement of water. But we see some reduction also in the base flow. Again, we cannot complete it with this small project, but we've seen some reduction if you look at the numbers again there in terms of how much water gets to move to Lake Tanganyika. As I said, similar to quick flow, base flow will also contribute to increasing the water levels in Lake Tanganyika. Recharge is statistically insignificant because what the model does, before the model absorbs or allows water to percolate or infiltrate into the ground to recharge the groundwater aquifers, what it does is it has to first take care of what? The water needs of the plants that you are planting there. So remember from the hydrological cycle, we know that all of the water that is coming, some of it is needed for plant growth. So that's the portion of the water that is being absorptive, and it minimizes the potential to recharge the groundwater aquifers. So the recharge potential there we saw was very, very minimal, not significant. It's very small. But again, it's positive, but it's not significant. So this is the summary of the findings there. Sediment. Now let's talk about sediment. Our sediment model looks at sediment movement, right? And it looks at a number of issues. So what we are trying to figure out with sediment delivery is how much sediment gets to move on the soil, and that is calculated using the revised universal soil loss equation. So basically, what's the soil loss that you get? Why is my computer kicking me out? It looks like I just got kicked out again. I don't know, maybe I need to. So with sediment, we're looking at soil erosion, and we're looking at how much soil is lost on the landscape, again, considering input data sets that we put in there. But also, it gives you an idea of sediment export. How much sediment gets to the stream as a result of the land use type conditions that are there, as a result of improvements upstream. Like I said, how upstream improvements, restoration minimizes sediment export into the stream. So it also looks at sediment deposit. How much sediment gets deposited on downstream pixels? Remember, not all of the sediment that moves from the first pixel upstream there makes it to the stream. Some of the sediment will be deposited along the way before it gets it makes it to the stream. So it models that soil loss total. It gives you sediment export. It gives you sediment deposit as well. So let's see. So these are the data needs similar to the water yield model. This model also requires a lot of input data sets, rainfall data, land cover, land management type, those are factor variables that you put there. The K factor, also the soil type. It looks at, as well as the digital elevation, because now we are looking again as a hydrological model sort of, because it thinks about upstream downstream interaction. So you want to know the elevation of the landscape. Why is this important? Of course, this model helps us to kind of have an idea of reducing soil loss. Okay. And the benefit is that it reduces soil. Once we know that we do an intervention, we can minimize this loss of soil fertility loss. It also helps us to understand the treatment cost, because once you get all of this sediment deposited somewhere else, maybe there's some treatment needed. and then the like. So the output data sets you get are, like I said, I've already explained these things, is the export. That's the total amount of sediment exported to the stream per watershed, as well as the total amount of potential soil loss in each watershed, calculated by, it should be the revised universal soil loss equation. And the sediment retention is interesting because retention, what it means, if you compare your current land cover to a hypothetical land cover or watershed where all land use is now converted to bare soil. So imagine if you deforest the whole area, now everything looks like bare soil. What happens to sediment retention? Basically, you get a significant loss in soil because of that. Deposit is the amount of sediment deposited on landscape in each watershed. So results here, notice that in this case, it's interesting because the darker, these darker brown colors are showing where soil erosion has the greatest impact. And notice that we are seeing a lot of that upstream, but also downstream is not zero though, it's not. If you zoom in, you'll see that there's soil moving, but a lot of movement is happening upstream. And what this project intends to do, for example, if you look at here, this area here, this area was a reforested area, basically from degraded land to reforested. You can see that we minimize the sediment dynamics, basically sediment export moving, as well as sediment delivery that end up coming towards the stream. So that's been significantly minimized around this area and some of these other areas here you can see. So the idea is that nature-based can help to minimize sediment export, and minimizing sediment export into the stream has significant marine benefits. It prevents water pollution and all that sort of stuff. So that should be it. I would stop here and let's go into a conversation mode.
Thank you for the presentation. I think we have some questions already. So we have here, someone is asking, does this model take nutrient loads into consideration? If yes, what nutrients have been tested so far?
That's a different model. It's a great question. So we have a nutrient delivery model too. So that's a different model, not these ones that I've presented. So we have a specific model to look at nutrient delivery.
Okay.
I can put the InVEST website in the chat. So people, I encourage you to, one thing about our tools, there's a lot of user guide materials available for you. So, and there's an online community that is there to answer your questions. We have a whole software team, if you join our platform online, that can answer any questions that you have while you're running the model. If you are experiencing some technical challenges, you can describe it and they will help you resolve either some bug or issue it may be.
Okay, so I'll take the second question. So another person says, great presentation. Could you talk a little bit more about the 4 types of carbon? I would appreciate if you would also explain a little bit how carbon stock was measured in Burundi, how you measure the carbon stock in the projects you just talked about.
Yeah, that's a great question. So we're looking at biomass, right? And we are looking at 3 pools. We're looking at the stock of carbon that you get from above ground biomass of the 3, as well as the below ground biomass. And you have the soil carbon and you have the dead carbon. Now, how do you get those numbers? That's the question, right? For each of those levels, you need to have in the table, I don't know if I show you that table, but for each, so you have a table like this. On the columns, you have the carbon pool, types. And then the rows of the table, now you have for each land cover type. For forest, you want to know what is the above biomass for that given location. How do we get that number? Sometimes we can get that number from the government, from internally. Sometimes we get that number from the literature, previous studies that have done it. Sometimes we don't get it from both, and we estimate it. How do we estimate it? We estimate it comparing the vegetation type that we observe or understand to be present in Burundi to similar vegetation types elsewhere. Maybe you can think of Burundi, compare Burundi to Rwanda, for example. So maybe we see some similarities in the land cover. We could do that. But it's a very important question because the model is like garbage in, garbage out. Whatever numbers you give it to the model, it makes a calculation based on those numbers. Okay. So you have to do a thorough job in getting the right numbers. Don't just rush, because you can easily run the model. If you have that number, you can easily, but where it takes time is for you to do your job, do the right consultation, do the literature review, and get that number for that country. That is how you do justice to it. But at NatCap, we have default numbers that we globally, now our team has, we're trying to help people globally to get the numbers for different zones, climate zones around. But despite those numbers, you still can use more accurate numbers, nationally available or regionally available numbers. Maybe that makes sense to you.
So in the absence of any more questions for now, I do have a couple of questions for now.
Mm-hmm.
So I was just wondering, you did mention you work with the World Bank. So I was just wondering the connection between NatCap and World Bank, because I know NatCap was developed from Stanford University, and then you work with the World Bank here. That's one.
Yeah.
Okay. Should I go ahead?
Well, I can just knock that out if you want. So like I said, NatCap is a multi-institutional partnership. If you can want to call it, the headquarters is in Stanford. University of Minnesota was a co-partner, co-founder since 2007. Because NatCap is co-founded by the University of Minnesota, I am a university employee. I'm a research scientist at the Institute on the Environment, which houses the Natural Capital Project. So my role is to direct that program. Of course, I do my own research. That is, some of it is not natural capital related, but most of it is. How is this connected to the World Bank? I have to say, the World Bank, my work with the World Bank is an independent consultant, is an independent research climate scientist that get hired by the bank to do the work.
Okay.
However, Natural Capital Project and the World Bank have been partnering to do a lot of work from Burundi, because in the Burundi work, we work with NatCap through Stanford. Even though I was an independent scientist there, we were formally working with NatCap through Stanford. That work now gets scaled up to many countries in Africa. They're doing this Bella project, their landscape assessment. And I also wanted to point out some resources that the World Bank and NatCap has done. We've done a study on the economic case for nature. So it's a global assessment. I encourage you, I can put the link in the chat in a bit. But it's a global assessment that looks at what is nature's contribution to development. Basically thinking of nature as a development asset. And how do we introduce nature smart policies that strengthen our climate resilience and reduce vulnerability. There's also another big study just completed on natural capital index that NatCap and the World Bank also find. There's also a global level that looks at the natural capital index. It's an index for every given country, for almost 143 or something countries, over 100 countries. So those are big projects that NatCap and the World Bank has done formally, and there are more in the pipeline. That's a great question. Yeah.
All right. Thank you very much, Amara. There's a third question actually that somebody asked. If I may just read it, or I don't know if Chinonso, you can read it quickly about mangroves.
So, yeah, I can read it. So someone is asking, can the carbon model be applied in marine environments? There's a carbon project undertaken by the Kenyan Marine Fisheries and Research Institute using mangroves. How different is this model? How different is this model to that of mangroves?
Mangroves applicable. Mangroves, it will be applicable. Yes, mangroves, it should be applicable. But if you're thinking of ozone carbon sink, that's a different game. The carbon that the ozone sequester, that's a different game. This is terrestrial. It has to, the mangrove, even though mangroves may be on a wetland or something, coastal area, that it can deal with. But anything that is the carbon that the ozones take, we know there's a significant portion of the carbon is being sequestered by the oceans. That's not this model. We don't have, I don't think we have a, well, let me check, because every time we have a new models. But not this one that I presented. Let me check quickly if we have one for that. Yeah, but it's a great question.
While you're checking.
So we have coastal blue carbon though, yeah? We have a coastal blue carbon, which is different from our carbon storage and sequestration. So the coastal blue carbon, let's see here, it says, this is marine and terrestrial ecosystem. Marine and terrestrial ecosystems help regulate Earth's climate, blah, blah, blah. Let's see, this model make use of a variety of inputs to distribution and abundance of coastal vegetation, habitat-specific carbon stock data, impact characteristics of various land cover distributions and disturbances to biomass and soil carbon stock pools to predict carbon emissions rate. So I'll put this in the chart. It looks like we have coastal blue carbon. Maybe this is the one you want to think about when you're doing the mangroves. It looks at also above ground biomass, the dead carbon, that's the litter, the below biomass and soil carbon. So it's similar to the one I presented, but if you want to do something around mangroves and around the ocean, you may want to look at this one. I'll put it in the chart here.
Okay.
We also have a coastal vulnerability model. For those of you who are interested in coastal vulnerability, that may be a good one to look at. Coastal vulnerability, I'll put that in the chat as well. Yep. Yep.
Okay. Chinonso, I think there's a fourth question that just came in.
Okay. Okay, so someone is asking, can this model work for seagrass and salt marsh? Also, can we have the link to the model for nutrient load? Thank you.
Seagrass
and salt marsh.
Yeah, I will check in the carbon, the blue carbon model for that specifically. That's a very specific question on. I don't want to give misinformation on that. Let's double check on that. That is good reference to check for that. Yes, I'll put in the chat the nutrient delivery model link so you can access that.
Okay.
Let me show you something. If I can read project again, let me show you something real quick. So let me show you this. How do I do this? I want this guy up. Okay, one here.
And also,
Yeah.
while Famara is searching,
So here.
okay.
So this is now what we call our InVEST workbench. So if you download first, before I do this, let me show you this. Let me just go to the website. So if you go to the website, let's just say, where is it? Natural Capital Project. If you go to the website, you just go here, InVEST. You click here. Here you can download. If you have a Windows or Mac, you download. So once you download, and down here you can see the model, all the models that we have. We also have flood risk, urban flood risk mitigation, water purification, all this stuff, habitats. So let's stop sharing here and let me show you this one real quick. Okay, yeah, okay. So if you download the workbench will look like this. So here you have everything in one place, which is great. So you want to look at each of these models, run each of these models, you can just do it from here. You want to look at the carbon, blue carbon, that's it. You start to input your data. It tells you what you need. Here it gives you more information. If you want to learn more, you can still click on the user guide, or you can access that here. You can see frequently asked questions. That takes you to the website. You see that this website here, which I don't think at this point you can see, but I want to show you the website real quick. I think that's also interesting. So if you look at this, those frequently asked questions, once you click on them, it now brings you questions that people have asked while trying to figure out what's going on with this data or model. So now you are now working in a community pool where you see answers to previously asked questions, you can ask new questions, and there's a whole team dedicated to answer these questions. So you can see a bunch of questions about negative carbon stocks, and maybe that question on seagrass and stuff, you put it here, quickly you'll get an answer. Yeah. So, or you can spend a lot of time, not a lot, but I think it is worth it. I think it is really worth it, especially if you're presenting these models. You want to make sure that at least the user guide, you read every text in the user guide. You may not understand some of the calculations, you may not, but at least have a working understanding of what's going on. All right.
So thank you. So there's another question. Someone is asking, can the InVEST model be used to analyze trade-offs in provisioning ecosystem services in wetlands?
Trade-offs, yeah, trade-offs, wetlands. Wetlands, what exactly are you interested in the wetland? Which ecosystem? Because wetland is an ecosystem. Which service are you interested in? Once you know the services that you are interested in, then you can now look at the models that we have. For example, wetlands on water purification, for instance. You could get an idea of ecosystem service value related to wetlands functioning in helping to clean water. So that's one example. So maybe wetlands, in some cases, even on the carbon side, if you look at the blue carbon model, maybe there's an important sequestration value that wetlands offer in terms of stock getting the carbon in. So first, most terrestrial ecosystems, these models will work for them, but then you have to identify what ecosystem services are of interest to you. Once you know that, then check what models that we have, and then go into the details of that, and then.
I think that question was specifying provisioning ecosystem services, right?
It was. Does it say provision?
I don't think so. Let me see. No.
Because
Okay, yes.
if it is,
Okay.
let's think
Provisioning,
of,
yes.
if it is provisioning, let's think of wetlands. What are wetlands providing in terms of,
Mhm.
when we say provisioning, normally we think about food. Maybe wetlands are
Food.
providing
Fish.
fisheries.
Mhm.
So if it is fisheries,
Mhm.
then if it is fisheries you want to model, I don't think we have that from wetlands. We
Mhm.
don't have that. We have crop production model as a provisioning service, but wetlands are not giving us crop. I mean, unless you're putting rice there or something. But in this case, fisheries may not be a product that you get. We have pollination, another which is an intermediary service, supports production,
Mhm.
but yeah, we don't. I don't think we have a fisheries specific model on provisioning.
Mara, I have one very practical question. One issue that generally comes up when we use desktop applications for modeling anything is generally the
Yeah,
data structure, the structure of the input data, the input file.
yeah.
So can you please say something to that? And do you have a file that you can kind of demonstrate this so that we can see how it looks like, the structure, and how to kind of arrange it, the table?
Yeah. So the structure and the format.
Yeah.
So if you think of these models, a lot of your data is spatially explicit data sets. So you
Mm-hmm.
want you want GIS files, most of them. So I'll show you. Show you here on the workbench. So here, let's go back and look at one of the ones that I spoke about, the seasonal volume. Now, the interface gives you an idea of what you need. Here is your directory. This is just a folder where you want your results to go. So
Mm-hmm.
you click, go create a subfolder somewhere. It's going to upload that folder right there. So everything now is generated, is going in there. You want specifics as you change, for example, in this scenario, we can say scenario 1, you want to add something here, scenario 1. Now, every result that is generated, it will have a suffix, right, that says scenario 1. This way, it distinguishes it from the others. Land cover, it says, what do you need? A raster file, and that's a TIFF file.
Mm.
So this is a GIS layer. So it will tell you what it is. But you have to get it somewhere. You store it somewhere in your desktop. So go to that. If you click on this, it basically takes you there. So you get it, upload it, and then it comes in here. Now my computer has been very slow because it's been almost 3 weeks. I never restarted my computer. I need to do that after this meeting. Okay, so for this model, you need a biophysical table. That biophysical table is the table that corresponds to the land cover map. It's an Excel format, CSV. What it does have, it has on the rows, right, the land cover ID. So think of your land cover from forest to everything that you have. In the raster file, you must have an ID. That ID for forest must correspond with the ID in the CSV file. This way, the two are talking to each other, right? Plus, once you have that, then everything else, you will see the columns, everything else, if it is your carbon data, for example, everything else will follow. If it is maybe your other biophysical indicators for this particular model, those K values will follow and the like.
Okay, so you also have like the geocoordinate data in there.
Geocoordinate, yeah. So the coordinate system has to be the same. Your maps must be projected on the same coordinate system. You cannot have different coordinate systems to run it. And everything must be in meters also, because in meters. So there's some GIS work that there's a little bit of GIS work in there, but I don't want people to be scared of the GIS part of it. But you have to understand that, because if you don't have those things lined up, your model will not run. So then you are confused. You're like, what's happening? Those are the basics that you need to understand. The projections must be the same. So often before I do this, I go on my ArcGIS Pro, or I go on QGIS, make sure that I get the maps all in the same format. The IDs are correct. The tables are all lined up before I open this. Once you open this now, it's just a matter of 10 seconds or 20 seconds, or maybe even like a few minutes, right? Once everything is lined up, you run it. It takes a few minutes, depending on the area, it takes a few minutes to give you results. And once, if you have those results now, you have to go back to your GIS platform again, reload, because it's giving you spatially explicit maps. You now load in the results and format it. Just like now you have a map. You have like those nice maps that I was showing you. Now you can format those maps, use any color type that you want, do your nice labeling and everything else, and then get those results exported. So you now move to GIS, but this is not doing visualization for you. This is just doing it's just spitting those results for you to go elsewhere and format them and then do the right visualization that you need. For some of the models you see here, of course, it's mostly, this is a text, is a default. So these numbers are given. You have those default alphas. If you look at the user guide, it will tell you what to put there. But again, most of them are here, for example, is a directory. So this one is interesting because this one you have to create a whole folder, right? And for ET, your folder should have 12 maps, and each map represents a month of the year. So from January to December on evapotranspiration, because we know that January ET is different from March or April. So for each month, you want to have maps for each month. And then there is a specific way you have to label them. All of that information is given to you. So if you click, you go to the user guide again, it tells you how to label or title, if you like, the maps in that folder. Once you click on this, it takes you to that folder, and it now knows that you are now picking a folder instead of a file. So it brings in the whole folder into the software. Similarly, you do the same for the precipitation on monthly data. Does that make sense?
Yep, perfectly.
Yes. So that's how. So you move in between these two different platforms.
Okay, thank you very much. Chinamso, I believe there was a Google Doc with questions.
Yes, there was.
So should I read out the questions, or do you have access to it?
Yeah, I have it here, but you can read it out.
Okay, so let me see. Okay, so I think some of the questions, Famara, have already been answered by you, but I'll just run through them. These are the questions which were put in this file before the webinar. And so the first question is, how does the InVEST model incorporate ecosystem services in its analysis? I believe
That's
a
great question.
Yeah.
That's a great question. But overall, all these models are ecosystem services. First of all, what are ecosystem services? Everything that we talk about that nature provides. These are services that nature provides, and often services that we don't pay for, right? We know carbon storage. We don't go and put some technology out there for that. Nature does that for us. We know water seasonal water, the way water moves on the landscape. That's all. These are all ecosystems. So essentially, everything that we do are ecosystem service models. Every model here are ecosystem service. Now, why this question is interesting, I think, it's the change in terminology. The literature has been sifting from, okay, ecosystem services, now we call them nature-based solutions. Now we are also calling them nature's contribution.
Contributions, yes.
Nature's contribution to people, that's the NCPs, those kind of things. So there's a shift in terminology a little bit, but they're all ecosystem service models.
Okay. And the second one is, can you explain the data requirements and sources for implementing the InVEST model effectively? So data sources and requirements.
So if you think of InVEST, think of it as a bunch of models. And each model represents an ecosystem service, one service. Carbon, water, air pollution, sediment, cooling, all that stuff. Now, your data source, on our website, we give you open access data that you could use to start with. So some of the models you can run using globally available data sets. For some of the models, you need some additional layers. Again, you can replace the globally available data sets that we have with better, really, data sets. On, for example, land cover, take land cover. You have land cover. We now have 10-meter resolution from ASRI using Sentinel-2 data, right? That's now globally available. But man, I look at that land cover, sometimes I'm like, I'm better off just doing my own land cover class classification for some countries, because remember, ASRI is doing a global assessment. And I don't know how the algorithms are moving to do this, picking their samples and do the classification. But sometimes I've done work, for example, I've done work in Bangladesh. I know 100%, even if I show it to Bangladeshi, I know the land cover data that I classified myself using ArcGIS Pro has a better, classification than the ASRI data set. So that's a clear example to say, instead of using ASRI globally available land cover data, I'm just going to use my own data. So data is out there, replace it as you need, but we have something to start with.
Okay. Thank you very much. I think that's a very important specification. And for our young researchers, that's something you should take into consideration as well. The third question is also a very interesting one, and it goes as follows. Are there any limitations or potential biases associated with the use of the InVEST models, especially when considering different contexts or geographical regions?
Great question again. For each model, if you go to the user guide, it will tell you the limitations for each model. So limitations will vary by model. I gave an example of the carbon model. I gave you an example of limitations related to the linear projection of carbon. We know naturally carbon doesn't work like that. But the model is very simplified. It gives you something better than nothing. It's pretty good. It's been useful to inform decision making. So limitations are model specific, and from our perspective, we give you all the limitations that you need to know about for each model. For every user guide for each model, you see a whole documentation of what is the theory behind this model. What are the data sources? What are the input data layers? Where do you get those data layers? What are the results? How do you interpret the results? What are the limitations of the results? So it's a very good documentation that you have to, like I said, before running these models, please read the user guide.
Okay, so if I may just follow up on this question, focusing on the carbon model, is there any way, and I believe it's possible, to integrate aspects such as how temperature might influence carbon sequestration, and also aspects such as variables such as the vegetation type, maybe the foliage type, because not all vegetation sequester carbon the same way. So is it possible to integrate this in the model and then increase the confidence of the results?
Vegetation, yes. So the model is as detailed as you want to do. So for some places, you have a very detailed land cover map. You go forest, it's not really forest. They will say forest, you have different types of forests in that country. Right? So you have to differentiate. When you say forest, what type of forest is it? So as you differentiate it, you have to also differentiate the stock for each cover type. And even grassland, you know, some places you have grassland, you have woodland, you have savanna, all these different types of grassland. The more detail you provide, the better for you and for the better results that you get. But remember, the more detail you go, the finer you have to also go on the stock data. If you say different types of forests, now you have to differentiate what makes this one different from that one and from that one and from that one. So you have to do all of that. We can do that. You can have 100 land cover types if you want, 100. As long as you have numbers for each, the model will run. Temperature is a different beast because this model, the way it is set up right now, you cannot bring in temperature data into it. If you want to do that, you have to do that outside of, sometimes we call it outside of InVEST. We have done work that was like done outside of InVEST. You go now with all this Python work and everything that's happening online. People, you can, sorry, I just said Mandinka. I just said my local language. So that means, so if you go outside of InVEST, what you get is you have our model open source. So suppose you say, I don't want to download this stuff. I'm a data scientist. I know how to do coding. We're going to give you the codes. The codes are actually openly available for all of these models. You can take those codes, manipulate them, change them as you want, right? Improve it, bring in new data sets and work with it and then get whatever you get. So it's open source. That's the good thing about open source. You can take what people have done and then you improve it if you want. But if you're using the workbench, you have to stay within the parameters that we provide. If you want to get outside of that, you want to do that outside of InVEST.
Okay, that's actually very interesting. And I'm happy that there's this freedom to use the code to use in other platforms. So I guess our data scientists would be, could get to work and that's why I think having the marine environment, wetlands, and all of that are not currently within the InVEST framework, it becomes a lot easier because the code can be used in, let's say, Python and change the parameters.
Yeah.
That's really good. Okay, so the next question of Chinonso, how are we doing with time?
We are over time.
Okay, good. If Amara says we have time, then we have time.
No, I don't say. I say we are over time.
Over time. Okay. All right. So,
yeah, if we can wrap up, I enjoyed this discussion, but like I have 1,000 things that I needed to complain. Again, sorry for starting late. But...
No problem. No problem. So we have a few final questions, which I'll read very fast. Okay. So the next one goes as follows: how can stakeholders be involved in the process of utilizing the InVEST model for decision making?
That's a great question.
Yeah.
So it's a great question. First, I like to work with stakeholders to begin with. your stakeholders, if the stakeholders know what they're interested in, some stakeholders, they have something very specific that they're interested in. On mangroves, for example, some stakeholders maybe just wanted to know mangroves as coastal defense mechanisms. How can we leverage the power of mangroves to reduce coastal flooding? If that's what the stakeholders are interested in, then now you bring them to this right model that answers that question. But you can, at the same time, in nature, when we work with nature, we say, how about other co-benefits? Mangroves provide, of course, the defense mechanism, natural defense system, but they also provide a significant carbon sequestration potential. Then we offer something else. And then we go ahead and say, well, besides that, mangroves also provide some provisioning services. Again, that may not be InVEST. We may not have to do use InVEST for that, but we can find other methods to calculate the fisheries potential or the stock that you gain with the restoration of mangroves and all this stuff. And maybe you would also look at water and other stuff. So you provide all these different services, but first listen to what your stakeholders are interested in, see what we have specifically to answer the question. You can work with stakeholders. Stakeholders love maps, by the way. People love to see maps. If you have very nice maps, they want to see those things.
Yeah.
So yeah, I think that's a way to get them involved.
Yeah. And the next question, I think it really ties into the previous two questions. It's are there opportunities to customize or adapt the InVEST model to suit specific local conditions or priorities? I think.
Yeah, of course, a lot. Because remember I said, InVEST is a tool. It's like a framework. What goes into it, you decide. That's where the customization happens. So you decide what goes into InVEST. So you can go as fine as you want. You can customize as you want. You can bring in nationally available data as you want. As long as it's in the right format, InVEST will run. Outside, also, I've said that InVEST is open source. So if you don't want to work within the framework of the desktop version, you can go on Python and work with it there.
Okay.
Perfect. Call on InVEST and modify stuff and do whatever you want to do. So it's very possible.
That's nice. Okay, this is one that is really important to early career professionals, and it is the kind of capacity building or training that is necessary and available to use InVEST models effectively.
Start with what we have on our website. We have tutorials there. You just Google Natural Capital Project, go on there's a bunch of links. Go on YouTube. There are lots of training materials there specific to each of the models. So if you're just interested in learning more about carbon model, just go and put it in YouTube. Search that in, you'll see somebody talking about it. Actually, NatCap are talking about it, providing more details. Do that. If the team, for example, also want us to do some project, like real demonstration project, or even training, we can also think about. I have to be honest, I don't have budget for you. You and I have talked about this before. I don't have budget for it right now, but we can think about how to mobilize resources to gather, some experts to do training for each model. Yeah, but a lot of what you may need is already available. Don't wait for any formal training. Just go out there, get the knowledge. Even if you come to training, you already know the basics. And yeah. So that's my advice.
Yeah, thank you. That's a very good one. And then there's one person who asked the question to know whether we can use InVEST for species distribution modeling.
Oh, habitat. Let's look at what we have on the habitat list. I would put that in the chat.
Okay.
We have habitat quality. We also have habitat risk assessment. So I'm going to put habitat risk. This would be a great resource to take a look at.
Okay.
Yeah.
All right, thank you. And then the last but one question, how can communities, I believe this is also closely related to the previous questions, but this one is mainly on communities and organizations. How can they access support or resources to implement the InVEST model in their projects?
Another great question. You know, I would say basically it depends on what resources they need, right? InVEST is open source, it's free for anybody to download, anybody to use. Yeah. So do they need somebody to run the model? Maybe they could hire somebody who knows how to run InVEST to do it. Maybe they need us to do it for them. We've done, like, for example, just a few days ago, I've been in contact with a county in Iowa that is interested in us doing some InVEST runs for them. So I brought in 2 students on the natural capital project that are doing that, for example. So if you need, if team or projects or communities, organizations need us directly, like the World Bank, they consult us, we do the work. Sometimes they don't need us, they just need someone who can do it. Put a job description out there, somebody who knows how to do it will apply. But again, we don't license this model, you don't have to pay anything, it's open and free, you can download it, run it just like me, interpret the results, as long as they make sense, that's it.
Okay. And then to follow up on this, if the communities, let's just say our local communities in Africa, right, they need some kind of support from you guys, the experts, to run models in order to maybe assess the ecosystem service, the value of the ecosystem services and habitats. So would it be possible to get into some kind of arrangements?
Yeah. You see, it's similar to what we've done. Sometimes getting our team members to do this, you know, we have self-funded. We have funded based on projects. Getting our team members to do this, we need to get some funding. So it's like, in this case, World Bank funded it, so we did the work, and then the communities get the result.
Okay.
But like us going directly to, you know, providing our own resources to the communities right now, there's not much of that available. There are few cases where we can do it without much funding. There is always funding needed for us to do the work.
Yeah. So in this case, we would really want to come in and help communities by writing proposals.
Yes.
And maybe consult you to be part of proposal writing process.
Yes.
Then get funding to do the work. That will work.
That's a great one. Also, if many of our audience here are from Africa, I have a special interest in advancing and bringing this work to Africa. Through our engagement in the UN climate discussions from the University of Minnesota, so I've been going to COP meetings. I was in Bonn also for the SB meeting. What I want to do is that work with people like you who are researchers and scientists, working perhaps in your own countries. You don't have to be based there, but interested in working in your country. Then we have an entry point through your work or through you to kind of provide these results and these analytics to the government. Because I'll tell you, this work is becoming more important than ever before. If you look at loss and damage negotiations, for example, they are talking about economic, but also non-economic losses. And what do we mean by non-economic losses? We're talking about loss of ecosystems and ecosystem services. How do we present a compelling, a data-driven scientific approach that provides evidence, right, beyond doubts to decision makers to be like, these are the ecological damages that climate has contributed in our own context. Because remember, loss and damage, as it says, loss and damage, you have to prove it. It should be proven beyond doubt that this damage, this loss is climate attributed. So that attribution science, our models can help identify some of the degraded losses and ecosystem losses over time. So keep me the list of people. I hope if I'm also in Ghana, this is what I want us to talk about and get some recruitment and get specific names for specific countries and get a team working together to advance that agenda. I was also thinking of going to the Africa Climate Week in Nairobi, where it's the same spirit of, again, engaging and building relationships, getting people interested in this work to contribute to the climate discussions that are happening in Africa and globally. So that's very interested in that.
So I will probably send you an email because we are already also preparing ourselves to be there in Nairobi for the climate meeting. So hopefully we can also meet there in addition to meeting Ghana.
Yes.
We can arrange some side meetings, to discuss with a few policymakers as well.
Yeah.
That'll be fantastic. All right. The last question, very last one. I am interested in data acquisition to map coastal vulnerability. I believe we talked about this already.
Mm-hmm.
Can I have a broad explanation on how to get all the data needed for that mapping? I think you already explained that. Maybe you just...
I did. Look at the coastal vulnerability model.
Yeah.
Read the user guide. The user guide will give you links to various data sets. Go into those data sets, see if you are able to download them. Use ArcGIS Pro or ArcMap or QGIS. Do your own basically GIS work that is needed, because for some of the globally available data sets, remember, these are global, either African level big images, so you need to clip them to the study site. So you have to do some cleaning up. So if you do all of that, try to save the data somewhere in your desktop, download the app or the tool software, try to work with it and see if you are experiencing challenges. Again, in the workbench, you see frequently asked questions. Just click on that link. You'll have access to a whole community. They're sitting down in Stanford. Most of them are in Stanford. They're waiting for you to ask them questions. That's their job. They're just sitting down waiting for questions to come. So send any type of question. But I would say, do your background work first. It's not bad to ask stupid questions, quote unquote, but let's just put some little effort or resources to do our own background work. Meaning, read the manual. If you don't understand it, go ahead and ask as many questions as you want. But
all right. Thank you very much. This has been enlightening. Chinonso, you can take over.
I just have a question, a quick one. That's okay.
Yeah.
So I did use the InVEST coastal vulnerability model, and I needed help with interpreting my results. And when I went to the online community, they said they don't help people interpret their results.
Okay, so let's look at it. So if you go, let's go to that. If you go to coastal vulnerability, I'm going to go to the user guide, and I'm going to go down to where it says interpreted results. So I'm going to show you this. So this is where we tell you how you should interpret the results, right? This intermediary outputs. Normally you don't need them, but they are here for you. But this will give you sort of an idea of interpretation of final results. So did you look at this before? You did. If you did, and you still have more questions, I can try to link you to one of our scientists who may be available to help with more interpretation. But first they will say, look at the user guide. So I want to make sure that you exhaust this. If you exhaust this, then you still have more questions. I'm happy to create some introductions for you. But again, it's so painful to go up to the results. You've made it all the way to the results, and that result should be interpretable. We cannot let you go without having those results interpreted.
I've seen all the videos on InVEST. Well, I think all, at least the ones that pertain to my work, and there are some results that the videos don't capture. I could be wrong. That's what I think.
Yeah.
Some results that the video don't capture about how to go about interpreting them, how to go about representing them. And some articles don't also show you that.
Yeah, now that you talk about articles, I'll show you something quick. If you go there, I'll go to our website. Where is it? So if you go here, you go to discover, I think here, is it resources? Or maybe research publications. So if you go under publications, all right, you want to look at coastal vulnerability. Sorry, super vulnerability. Okay, so there's one study, coastal vulnerability to climate change in China. Take a look at this study because it probably uses InVEST coastal vulnerability. See how they interpret this result, and then let me know if you have more questions, and I will introduce you. Take a look at this. I usually recommend if somebody has done the work, review that work, see how they interpret it. If you are almost using the same model, and you should be fine. I'm not sure if this study uses our coastal vulnerable. Very likely it did. So take a look at this and see. Yeah.
Okay.
Thank you.
All right. So, Chinonso, I know you still have questions, but we will probably have another opportunity.
Yes.
Now that we have Famara chained up here, I know we probably would want to have everything before we let him go. We don't know when we'll see him again, but I believe you've done amazingly well. In the short time you had, you've really touched almost everything that's necessary and that's essential. And it won't immediately give people expertise in the use of InVEST, but it opens up the doors for everyone to go the direction they would like to go in regards to their research and their studies. So thank you very much for that. And we hope that we'll have another opportunity and to discuss further, to have another a presentation like this, another discussion, you know, on specific applications of InVEST in Africa, and also linked to the various projects we'll be undertaking with regards to habitat assessment, you know, ecosystem service assessment, and valuations and stuff like that. So yeah, we're happy that you also have this in mind, you know, to contribute this to Africa, and we'll be working together towards that that goal.
I would say I'm here for Africa. Africa is here for me. So let's keep this community together.
Yes.
If you are working on a project, keep me involved as much as you want, and then let us know if you have results. You've done some work, let us know. We'll help to promote it. Like you see, we have a library. We have these publications. I'll show you one thing real quick. I know we're out of time. I need to jump into something else, but I'll just show this. Is that?
Not for us, you can keep going. So we wouldn't mind.
No, it's let's see. There is an impact project. So if you come under projects, these are all projects we've done. You check here, we've done a lot of projects, a lot of them in Latin American countries. This is where I want Africa to come. A little bit of Africa you can see here, Mozambique, and then the like, but a lot of it, US, Colombia, all that, Colombia, Costa Rica, all that, you know. If you look at the map, see all the places we walk. Look at where Africa is.
Exactly.
We need more dots in Africa there, because this is just showing a few countries.
This applies to everything, not just this. This applies to everything. But if that was a map of hunger in the world, you find all the dots in Africa. So that's something we want to try to change. That's the kind of dynamic that needs to kind of reverse somehow, not reverse, but just completely change.
Yeah, I want to see more projects here in Africa.
Yes.
It's through your work.
It is through efforts like this, like what you've started now. People get to know a little bit about what this is all about, and to know that it's not a mystery. It's not rocket science. Everything has been done already. All you need to do is do your background work and put in the values. You get the results. So I will encourage all of us here to really start looking into this. You don't have to be an expert to use InVEST. Famara's team and all the scientists who have contributed into this have done the work already for us now to just use it and give them thanks for everything they've done. So in the absence of a last word, I don't know if Famara, you want to maybe say
no, it's not much to say. Okay. Let's stay together, stay connected. Yeah. Thank you for your time. It's a pleasure. I hope I meet some of you soon, either in Nairobi or in Nairobi, Ghana, or maybe in Dubai or elsewhere.
Exactly. Yeah. All right. So have a very, very good evening. And you all have a good evening too. And Chinomso, thanks for moderating. You did fantastically well. So, probably see you all again sometime soon. Bye, Famara. Yeah, take care. All right, guys. That was a good one, and I hope that we learned as much. So, Chinomso, everyone is gone.
I think she's next.
Okay, so how do we get the recording?
So it automatically records. So I think I'll just drop the link when it's ready.
Perfect. All right. So thank you, Loretta, for your help. And see you soon then. Tomorrow, I guess. Yeah. Bye.